What I'm going to do first is look at this LOD 200 model we had a look at last week. And what I've done is the assemblies, if you can see over here, is very blurred on this crappy projector, but over here I've actually added a title block to it. So I've taken the assembly views that were generated by Revit just directly from this assembly that we made last week, and I just set it up. So that's pretty much a component drawing there. It gives us the overall main dimensions. It could do with some more dimensions in it, but it's got a plan, it's got elevations, and it's got a cross section. So if you work that up in a little bit more detail, you would have a good component drawing, and maybe a couple of better 3D views. You can make a decision as to how much detail you put in the schedules and so on, how much stuff is in there. But you can adjust your schedules based on it. But that is a kind of a standard component drawing for any element that you need to be manufactured off-site. So that's one thing. The other thing is I've set up this residential plan at 1:50 on this sheet here, which you'll be able to see on the video if you can't see it on the screen here. And if you remember last week when we added these assemblies, which we plugged into the model, I'm just calling this up as a revision. So this is revision A of the building. The thing to remember about revisions is you never make revision numbers if they're just revisions among the design team yourself, because that would be crazy because you're revising all the time, basically. The only time you make an official revision number is if you send it out of the office, because then it becomes a legal document. So you need to have a strong record of what's been going on in the design. So the other thing I've done is I've modified this sheet. So we have a set of a revision schedule at the top here. So this is where Revit automatically keeps track of all the revisions you have in your sheet. So for example, if I wanted to add another revision schedule of for window boxes, I come up here and I go to Annotate, and there's this button for Revision Cloud. So I click on Revision Cloud and I roll down here. Let's say I want to change this window here, for example. I just draw a Revision Cloud around it. And you can see over here it's saying, okay, this is number 3, stairs updated, and here are the other revisions I've made in the whole project. So I don't want it to be any of these. I want it to be a new revision. So I just leave the cloud there. We have the cloud in place. We know where it's going to be. But if I come over to the View tab and come over to another button for revisions, this actually gives us the schedule of all the revisions in the project. There's 2 ways of keeping track of revisions in a project. You can either do it per project or you can do it per sheet. Per sheet is a little bit more time consuming. And usually for large scale projects, you don't get to a per sheet revision situation until you get into the detailed design. It becomes just too much, because then you have to make a revision every time there's a change in the model. So if we keep it per project at the moment, you can see here I've got 4 revisions. The first one has no numbering system because this is just the first issue. So if you're sending your concept drawings out to the client, you don't give it a revision A, revision B. That would be ridiculous. You just send out the initial drawing number just to set up the drawing system. If he comes back and asks for changes, like he wanted to add these window boxes, or you've discussed it and you want to add them, then you give it a revision A. So you never change your drawing number itself, you just change the revision number. So let's say we want to put a new revision in there. I'm going to say add. And you can see, because I've chosen alphanumeric numbering, it's automatically given us a D for it. Well, you probably can't see it on that projector there, but it says D here. Now we have the option to change it to numeric or alphanumeric, which is numbers or letters basically. We can just go in here and type the date of the revision. You have to do this manually. So let's say, what's today's date? 27. So let's say 27/02/2017. And I'm just going to call this screen update. And I'm going to put who drew it, which is me, because I have no friends. Yeah, okay, well, let's make it capital so everything looks good. And then we can put in here who we're issuing it to. Or we can just say, we can just leave it blank, which means it's just an issue. So at the moment, I'm just going to leave it blank. So then I press OK. So now in the project, it's got a record of another change to the project, but it doesn't show anything up here. because it only shows whatever you're telling it to do on the sheet. So now I have to select this revision cloud and come up and change it to the revision I want it to be, which is screen update. And you can see that now the screen update has popped up in the revision schedule over here automatically. The last thing we can do then is go into annotate again, and we can use tag by category to actually tag the cloud and say, well, that's revision D. So now we know where revision D is, we know where revision A is, and revision A is in a couple of places because you don't just have to use one cloud. But we can also go in and do it per view. So I've done it, for example, here is just sitting on top of the actual sheet. But these revisions down here are actually in the view itself, so I need to activate the view to get in there. So it doesn't matter where you put the cloud. You can put it in the view or you can put it on the sheet. It has the same effect on the final revision. Okay. The other thing is, if we go into this one here, you can see that we can also add a cloud anywhere. Let's say this one here, and then we can give it the same. Let's call this one window boxes added, which is A, and then we can tag that one as well. Just go to tag, and then we have an A. If I was then to make a new sheet here, new sheet, just use the key one. I take this elevation, drag it onto the sheet here. You can see that it automatically populates the revisions that are in the view that we've made. So it's pretty smart. Okay, I think it's pretty smart anyway. What do you guys think? Huh? Okay, so how do you do that then? So how do you get your sheets to do that for you? So it is a family thing. It's a family situation. So we can select our sheet here. So here's our standard sheet. If I go into Edit Family, you can see that the revision schedule I've made is up at the top here. And it really is just a schedule. So the way you make it is you just come into View and Revision Schedule. So then you get the opportunity to add all these bits and pieces, whatever you want. You usually have sequence number, description, date, issued by, and issued to. Issued by is an important one if you're in a group, because you need to know who's done what drawings or who's done which revisions. So if I just press OK there, you can see it kind of sets up this this standard revision schedule, exactly the same as other schedules in Revit. But if I then go back to the sheet here and drag in this new revision schedule I've made, just put it underneath here, you can see it's got these standard ugly Revit graphics, these really horrible graphics that Revit comes with out of the box. So you want to be able to, modify it so it fits in with some kind of graphical quality, because graphical quality is important when you're sending stuff to clients. If everything looks like this, it just looks not professional and unfinished. So if we double click on it again, we have the options in here, just like you have in Word or whatever, to select a field here, and you can align it to the left, align it to the bottom. We can select all these fields here. We can change the borders, we can remove the edges and so on. We can change the font types. So you can actually modify your schedule so it suits your your office graphic standards. We can also, for example, shade it. So if we don't just make this really obvious, I'm going to make it kind of an orange shade in the background here, and press OK. And if I go back to the sheet now, you can see we've got this nice ugly schedule here. But it has also these huge example numbers. So let's go back in here again. You can actually come in here and say, well, we don't need to say revision number all the time. So we just call it reference, for example, or EF. We don't need to say revision at all, because we know it's a revision schedule. So we just say description, date, issued by. Well, we can say that. And let's just change this font to, I don't know, something like what have we got here? Century Gothic. That's not too bad. Let me go back in here. And it's something like that. And of course, we can just go back and we can keep going and change the schedule as much as we want. And then we can just place it wherever we want. We can stretch it around. We can change the order of the different elements and so on, until we get something that works graphically with our with our system there. If I then load that back into the project here and overwrite the existing version, you can see we have another revision schedule down here, and this one here also has another revision schedule down here. So we've set it up in two positions. This is the pretty one, and this is the ugly one. But you can see how simple it is. I mean, to keep track of the revisions if you start just using these systems. So let's just delete that one there. Load it back in again, and then we're left with just this one up here. So Revit then will populate all the revisions all the way down the page here. So it's a good idea to set up your drawings in such a way that you don't have anything sitting in this part of the drawing. I mean, many people might just draw a line down the side here so they remember as part of their title block. But the other thing we can do is, if I go back in here and edit it, you can see that what I've added in here as well, let me just delete it so I can do it again. We want to be able to show not just that the revision is at the top here, but we also want to have it at first glance. We want to see what version of this drawing it is. So the way to do that is to create a new label, and I'm going to put it here. And we want to make a current revision label, like that. And instead of calling it current revision when it turns up in the title block, I'm just going to call it XX or something. And then put it in there. We can also change the size of it. Let's change it to 2 millimeters. Oops, select it. Change it to 2 millimeters. So now there's an XX in here. If I load this into the project and override the existing version, you can see it's showing us, there's the drawing number 101, and then we have D just appended to the end of it. If we go back to the other drawing we just made here, you can see we've got revision A is shown at the end of it because it relates to whatever's shown in the individual drawing. Yeah? Does that make sense? Okay, I'm just going to pause that there for a second. Okay, so that was the LOD 200 drawing. So the basic architectural model, which is still flying in space, supported on these magical stairs. But let's close it down. Let's close this down too, and everything down. No. And no. And no. Okay, so last week we set up the different work breakdown structure, or large-scale work breakdown structure, the main elements, where I made one LOD 300 for structural and one for facade package, and of course you can make one for foundation, or you can make one for landscaping package. You can make one for anything that's going to be a large piece of work. So you can separate it out into a different package for a different trade to work on, whether it's the guys who are supplying and installing the concrete elements, or the guys who are supplying and installing the facade elements, or the landscaping, or whatever, because it's just easier to control that way, and also it's better for the software because it doesn't crash all the time. But if we go into the facade package here, now if you remember the facade package, let me just have a look at it. Maybe I need to, yeah, I'll just delete this for the moment. I'm just going to change the visibility of this so that the linked files are underlay and halftone on this view as well. So they're kind of grayed out. Not that it makes any difference because you can't see anything on the screen anyway, but don't worry about that for the moment. So let's say, for example, we have the architect's model here. Let's just put it shaded so you can't see anything on that. No. Okay. Let's say you want to make a package. You want to design in detail, at least in level of detail 300 at this stage. You want to design the cladding system that's going to go on the walls here. For a standard building, you don't need to because it's made of bricks or whatever, some simple system. But often, if you're dealing with a more complex building, you should really get into detail about designing the joints, especially if you're dealing with prefabrication. Designing the joints between the elements in the project are the most important thing. Especially if we come down to this lecture I made on prefab stuff at the beginning, if we just use this as the principle, we have these elements, which is the stuff, and then systems is how you organize the stuff. And that's kind of the simple way to think about it. But one of the tools in Revit that does that for you very simply is the curtain wall system. Now, usually a curtain wall system is for, stuff like this, where you can just make a very simple glazed element. But it has a lot more power for doing many, many things than just these glazed elements. So let's just have a look at how we would use it. So if I go into one of the plan views here, remember, we're using this architect's model just as the background, as the guideline for all the stuff we're going to make. So I'm going to make a new curtain wall. So I'm going to wall and curtain wall. And if I just start to draw that, let's say we start to draw it across the building like this, we'll just draw it from grid line to grid line. Let's just take that grid line up there for the moment. We can worry about it afterwards as to how it links up together. So I'm drawing it from grid line to grid line. And the idea is that we have a center line of the curtain wall here, which we can worry about afterwards. But we have also this kind of glazed element here. It's a very, very simple curtain wall. If I just, what have I got here? Yeah, just close this down. There it is there. It's just a very simple glazed element. It's got nothing in it. But we can change the top height, let's say. We'll change it to roof level so we know where it goes. So now we have the option to divide this up according to the paneling system that we want. Now, because we've made this according to a module, according to a 300 millimeter module, I'm just going to start by dividing it up according to that 300 millimeter module. Because before, when you're doing it by hand, you can draw grids to do it. But remember, we have two types of grids here. We have the axial grid, which is this one here, which locates the main structural elements. But now we want to make a modular grid to locate the panels. So it's between the panels. We want the two things to line up together because grids are important. So let's go into edit type here and duplicate it. I'm just going to call this cladding system. Whoops, there's my trademark, backwards writing. Cladding system. Okay. So now we have an opportunity to actually put in the curtain panel, which at the moment is none, the join condition, which is not defined, and the layout, which is the important thing, because this is our grid system. It even tells us there, vertical grid. That is slightly legible, is it? Sometimes I feel like I'm just talking. So we want to set it to fixed distance, because if they're standard panels, we want to make sure that they're all manufactured to the same size as much as possible, because it still is cheaper for the moment. So let's just make it the 300 module. And we can make the horizontal grid, let's make that a fixed distance as well, but let's make it a 600 module. And I'm going to click off adjust for mullion size, because we don't want it modifying the spacing of the grid according to the mullions being the framing elements between the panels. We want it to be always on grid. So I'm going to click those off. And if I press OK there, you can see we've set up a panel system that is a 300 panel system that also should line up with the axial grid. So now we have a modular grid that over the course of 7.5 meters lines up with the axial grid entirely. So now we've got our axial grid and our modular grid lining up, which is the important thing when you're dealing with panelized systems. So what we need to do now is start to design the individual panels. So this is where we get into families. I know you started on families last semester. I think you did quite a lot of stuff in families, didn't you? Bits and pieces. Huh?
Yeah, something at least.
Something at least. Okay, so let's get into making a curtain panel family just for these panels here, so we can get some modeling into the actual panels. Okay, so I go up to new family, and I'm going to use a curtain wall panel here. So this is always the template you use, metric curtain wall panel. I'm going to open it up. And we start with the plan view here. So we have the exterior view, so we know this is going to be outside, we know this is going to be inside, and we know this is going to be the center line of wherever we drew the curtain wall.
So I'm going to make this slightly parametric. Can you see those green lines? You can see the horizontal one anyway. Maybe not so much these ones. Okay. So the first thing I'm going to do is I'm going to try and get methodical about this, because if you start jumping into curtain panels like I did next door in the previous lecture, I completely cocked it up because I went backwards into it because I was just, yeah, never mind. But I'm going to do it completely methodically here. So hopefully this video will be better than the one I made next door anyway. So reference planes are what controls anything in families, especially if you want to make it parametric. So I'm going to make a new reference plane. I'm going to make a reference plane that goes from on this side of the panel and on that side of the panel. Now remember, this is supposed to be the outside of the panel, and this is supposed to be inside of the panel. So then I'm just going to add a dimension. There's a shortcut for dimensions right here. I'm going to put a dimension from here to here to here, and then I'm going to equalize them so that it's equalized around the center line of the panel. And of course, you can play with this afterwards as to what you want it to be. And then I'm going to make another dimension across the entire width of it, like this. And this is going to be my first parameter. So I'm going to make this the thickness of the cladding system. If I select this dimension, we get this option for labels, and there are no labels in the project yet. So I'm going to add a new parameter by clicking this button here. And I'm going to call this one cladding thickness. And it's a dimension, and it's a type, and it's a family parameter. I'm going to press OK. So now we have that parametricized. So let's just test that first of all. So I'm going to click on the family types, and we'll go into cladding thickness. I'm going to change that to 75, let's say, and apply. And we can see that it stretches in. So we know we've got control over the thickness of the cladding. Anyway, so we've done the plan view. So let's go into the exterior view now and zoom all so we get the whole thing in here. So these outline of reference planes is what defines all the panels in your, God, you can't see anything there. Can you see those lines? You can vaguely see those lines there. There's one, and there's one, and the ones at the top, and the ones at the bottom. That defines the panel that we're going to be designing. Because we're dealing with prefabricated elements, and when you get to specifying prefabricated elements, there's two things that you need to take into account from the architecture lectures. Is that there's a tolerance that you need to worry about in terms of manufacturing, and there's a tolerance you need to worry about in terms of assembly. And tolerances at a level of detail 300 are purely assembly tolerances, because we're only talking about how to assemble it on site. If we're at level to 400, then we'd be worrying about assembly in the factory. Okay, so that's where you start to add all those design elements in there. Because we're making a panel now, we have the opportunity to design all those details directly into the panel itself. So it automatically generates the correct tolerances, and it also gives us a record of the correct tolerances when we want to get some information out of the model. So I'm going to make some reference lines that are just going to define the tolerances. Okay, so I'm going to say create reference plane. I'm going to put one inside the upper level, inside the right hand side, inside the left hand side, and inside the bottom there. I'm not worrying about where they are yet. I'm going to give it a dimension now. So I'm going to dimension it up. This one here, this one here, this one here, and this one here, like that. So now that we've done that, we can select this dimension, give it a label by pressing create parameter. And I'm going to call this assembly tolerance. And it's under dimensions, that's fine. And once I've done that, I can hold down Control and select all the other ones and also assign the same label to them, assembly tolerance. And you can see that it moves those reference lines so that everything is 177. Now, in order not to confuse myself, I'm just going to go up to the parameters again, and I'm going to change the assembly tolerance we've just made. I'm going to change it to something a little bit more reasonable so we can see it on the screen. I'm just going to change it to 20. But it's not important. It's just so we can see it, that there's a difference between the edge of the panel and the actual edge of the object we're going to make inside the panel, which is what a tolerance is really, okay? So now we just have to start making the stuff. And I think what I need to do, yeah, that should work fine. So I'm going to say create extrusion, and I'm just going to draw a simple rectangular extrusion inside where we want it to be and accept it. Once I've done that, I need to make sure that these edges of the extrusion are linked directly, bound to these lines here. So when they move, that the panel will stretch or become wider or whatever. So I'm going to then just use the align command here. I'm going to select the tolerance and select the edge and then lock it. Tolerance, edge, lock it. Tolerance, edge, lock. Tolerance, edge, and then lock it. Okay, so now we have, if I turn on the shading view here, you can see that there is the object we've made, and there's a gap between the edges. There's the outside of the panel, and then there's a tolerance in there. So we know it's going to be smaller. So if you want to slot it in place, you're not going to be trying to do it millimeter perfect. Okay. So if I just, what have we got on the screen here? Let's close that one down. Close that one. Close that one. Close that one. Okay. So there's our kind of object at the moment. There's the panel we've made. So that's fine. So that's a kind of a base panel. That's not that impressive. But because we're getting to that level of detail 300, we can actually go in and start adding information to the edges that relate to the actual jointing information that we want to make. So as we've designed the panel, we can actually form the panel so that it has all those jointing edges. And the easy way to do that is to use sweeps. So I'm going to make, first of all, I'm going to make a void sweep. A void sweep. I'm going to pick the path. So I want to put it, this is the outside here, isn't it? I want to put it on the outside. So we know it's going to be there. I can zoom in and accept it. And then I can say edit profile. So now I can draw what I want to get out of this this element here. So let's say we take it across. Let's take it across 80. We'll take it down 45 degrees, and then we'll bring it out like this. Bring it up to the top, and then just drag this piece across the top here. And if I accept that, and then accept the sweep, it's kind of taken a nice bite out at the top of the panel there for us. Okay, so we've started to form the actual edge of the panel. So the idea is that this is the top of some kind of concrete panel, for example, and it's formed in such a way as that the bottom of the panel can overlap, so that it takes care of the majority of rainwater and so on. So let's just go ahead and form the bottom of the panel now. So let's do the same thing again. Create, instead of making a void form, I'm going to make a sweep, which is a solid sweep. Do the same thing again. Pick the path, so we know where it's going to go, and accept it. And now we can get in here and start editing the profile. Now I remember at the top I made it. What did I make it? 80 across. Anybody remember?
Yeah.
Yeah. So let's make it 90, so we know we have at least 10 millimeters in there. And I'm going to bring it down 45 degrees again. 170 should be okay. I'm not being too accurate about this, but it doesn't matter. And then we have a kind of a alternative. If I accept that and accept it again, and then I can join this element to this element, so they're all part of the same thing. So now we've got something that looks like that, which is kind of a good start for a cladding panel. It's only the external view of it, but that's okay because it's only an LOD 300 model. Okay, so let's save that. So I'm going to save that as a family. I'm just going to put it on the desktop, and let's call it where are we? 3J panel. Panel. Save. If then I press load into project, it's loaded it now into this project here. So let's just go to the 3D view. So now we can select this curtain wall cladding system, and we should be able to come in here and, whoops, I pressed the wrong button there. We should be able to, let's just select it again. Edit the type, and come down to curtain panel, and there we have 3J panel, which you can then apply to the system there. You can see. Now, you can see that you have to be conscious of whether you're going backwards or forwards or so on. That panel I've just made is probably a little bit big for the scale of the breakdown I've made. So let's just go back in here, and there's a couple of things we can do. First of all, we can go into the panel itself. If I tab until we select an individual panel, I can go and edit the type, and in here I can actually change the tolerance. And I know that the assembly tolerance I want in here, it's not 40 millimeters because it's always doubles whatever you have in here. It's 10 millimeters. I'm going to change it to 5 because it's 5 all the way around the edge, which when you put 2 together ends up being 10. So you can see it makes it nice and tight then. The last thing we can do with that, let's just move it out here. Actually, I'll tell you what, let's just hide this element. Let's see what works best on the screen there. Let's put on some shadows maybe. So you have a linked file that is nothing but a cladding system in it. Now once you have that, you can go around to the individual panels themselves or the individual grid lines and say add remove segments. So let's say we want to get rid of this, and we want to get rid of this one. Then we can say, okay, this panel here, I'm going to change from being just this type of panel to, let's say, either a glazed panel or a solid panel or just an empty panel for the moment. If we change it to empty, you can see that we've suddenly got an opening for our window system. So then all we need to do is to create a curtain wall panel that has a window in it. So you make a generic curtain wall panel that has frames and glass and all the information you want into it. That means you can just plug it into your paneling system. You can add the flashing, you can add the window sills, you can add all that stuff as you go up in the level of detail, as you get through the whole thing. Okay, any questions about that so far?
When we're creating the panels,
yeah,
like this for example, how much benefit would we have to put in a lot of parameters? Like the structure reinforcing, for example.
Yeah, that's what I was going to say next. Actually, is that you can use this because it's only an LOD 300 model. This is enough information, but
for this purpose.
For this purpose, but if you're going to get into actual construction manufacturing, I would start to add in at least the supporting structure behind it in the same curtain wall panel, so it would automatically generate the construction. You can add in face-based elements as brackets. And you can add in structural steel elements as supports, and then you can design quite a lot of detail the whole thing if you're only doing it as a curtain wall. So then you have an entire project that just as the curtain wall. It is full of the information that you need, and of course then what you can do is you generate a schedule. So make a new schedule, and you make a curtain wall panel schedule. And in here, you add area, count. You can add cost if you want to. You can add, what have we got? Type and height, or so on. And this will then, Revit will then calculate all the information in this project for you. You can see they're all under 1 meter squared. So you need to modify that over here as to how much detail it gives to you. But you can come in here and say sorting and grouping. Sort by type, do a footer, don't itemize it, give us a grand total, press OK, and suddenly we've got 497 panels of 600 millimeters height. We can work out how to get the width in there afterwards. But what I'm saying, it's generating the information for construction. We know how many we need now, we know how big they are, and where they have to go. Okay? I think that's probably enough for today in terms of information.